Hi everyone, in this tutorial I'm going to show you a quick and simple trick to simulate and work with millions of particles with the use of file cache and WedgeNode. Even if you have a low-spec computer, this trick will improve your workflow speed and be able to have millions of particles. It helped me so much that I use it almost in every project with particles or fluids. Hope you enjoyed this tutorial and it will help you improve your workflow and get better and faster results. But before we start our tutorial, I want to talk to you about our Patreon page and our Jammy, where you can support our work and allow us to keep doing these tutorials for the community. On Patreon, you get access to more advanced tutorials and project files by supporting us with a monthly subscription. On Jammy, you can request help with your VFX projects or request artworks to help your production or brand. Jammy works with a one-time payment without a monthly subscription. So if you enjoy our content and want us to keep doing these tutorials and work for the community, check out our Patreon page and Jammy. Your support means a lot to us and help us to keep doing what we love. Okay, so let's start with a simple PopNet particle simulation, right? So let's go with our particles. Let's dive in. Let's place the symbol here. Okay, let's go with polygon, increase a little bit the frequency. Let's add a mountain. And let's create something like a nebula with the millions of particles. Increase this. Something like this. Okay. Let's go create a null. Let's go with base geo. Okay, I like to have these nulls, so if we change the basic starting geometry, our system will update. Okay, so now let's go with our friend PopNet. Okay, and let's start with the simple stuff. Okay. Okay, so let's add some noise to move our particles. So let's put our friend Pop. Oops, what I'm doing. Pop. Okay. Pop, pop. And let's put our flow noise. Flow noise is a really cool organic noise, anti-alias flow noise. Okay. Really love this noise to create something organic. Go with 3D to 3D. Okay. And we want to displace our position, particle position. Okay. Cool. So let's go right click and promote input parameters so we can work outside. Let's see how it goes. Pretty cool, but let's go with more less frequency, a bigger noise. Okay, that is cool. Let's add a little bit of flow and self-advect 5. Let's see. Now I'm just tweaking some parameters to do it faster. Let's go with 0.5. And you can see how fast this simulates our particles. Okay. Right now we are just working with 1000 particles. Okay. Pretty cool. Maybe we can just tweak this a little bit. And now I'm going to add pop fluid. Okay. Some parameters to behave a little bit like liquid. Okay. Just to add a little bit of volume to our particles. Okay. I think that's way too much. Let's go with 0.0001 or maybe let's increase this to 1. Let's increase the viscosity a little bit and a lot our vorticity. Okay, now that's way too much. Go back. And maybe that's way too much, still too much. And I think this result is cool. Okay, that looks cool. So now let's see, let's go up. Let's finish our 150 frames. And at this moment, let's go without particles. At this moment, as you can see, we have 25,000 particles. Okay. We could come here if we want to work with millions. We could come here and increase this. Go with 500 as birth rate, and we will get more particles. As you can see, it is going to take a little bit more time to do it. And let's see how much time it takes to finish one row of 150 frames. As you can see, even my computer that has a really nice RAM memory, it takes a little bit of time, and I'm going to stop it because it is taking way too much. And as you can see, it is taking a lot of time, and by now we are just having, let me see, not even 1 million. We are working with 500,000 particles. And we want to go to millions, like 30 million particles or something. Instead of coming here and increasing this number until we get to the 30 million particles we want, we are going to leave this at, let me go, maybe 50,000. Okay. So at the end of this take, let's see, as you can see, it is going faster. Let's go. I don't know if you can see these numbers. Let me put play instead. And as you can see, it's faster because we have less particles. But with file cache and the wedge system, that little trick, it will make us run the file cache system multiple times, just changing a few parameters, and we will get more particles with that. It's just a nice way, a little nice trick, and easy to do and fast to do. A little trick to simulate millions of particles without having to run everything. Okay, so at this moment, at frame 150, we have 250,000 particles, and we want millions. So we are going to do a little trick with file cache and a node called wedge to run the file cache node multiple times and changing a few parameters on our .NET, and even if we want on our mountain. Okay, so let's place a file cache to start. Let's call it cache particles, and let's delete the heap name because I don't really like that. Okay, let's divide this, split this top and bottom, because I want you to see both, because the wedge node is on the out. Okay, it's on the outputs. So let's press tab and go to wedge. This little trick, this node, is going to run our file cache the number we want. Okay, so on the wedge output driver, we need to link that file cache. So just select this and drag here, or if you want, you can go here and select our cache node. Okay, go to objects, particles, and cache particles, accept. But if we press render wedges, it will give us an error because it needs a node inside this file cache. Okay, imagine this is a digital asset, right? If you double click, we have other nodes inside, and our wedge needs this node. Okay, so again, you can select this wedge and drag this here. Okay, or you can go here, select our file cache, press on the plus, and select this render. Okay, pretty much it. Now let's go to the wedge. You have the number of samples that we can go. So if we say 2, it's going to run this file cache 2 times. If we tell 4 or 8, it will run the number of times we have here. And this random seed is for the wedge parameters. So it is going to run this file cache multiple times, okay? But each time we want to change a few parameters, right? If we don't change the parameters, it will always look the same. We want just a little bit difference between each file cache, right? So in other words, if you don't add parameters or randomize any parameters inside this DOP network, it will always look the same, okay? So let's go to our wedge. Let's add one parameter. Let's go to our pop source and let's start by changing this seed. Okay, by changing this seed, let's go to the first frame. You can see here on the left, I hope you can see these particles. If we switch the seed, change the seed, you can see the starting particles, the starting position is changing. So we need to add that seed parameter to this wedge. So let's right click on the seed, copy parameter, let's go to our wedge and paste relative reference. This is a little nice way instead of writing this down. So this channel is already a channel input looking for a string, so you need to clean this up. Okay, instead of this, with this right click, copy parameter and paste relative is a nice way instead of and fast way instead of writing this down. So a name, let's add a name called seed, not set, seed. And this parameter is going to change between 0 and 1. We can change this and leave it 0 from 10. So we are saying that this parameter, okay, this one, this seed, each runtime, each file cache will have a different seed number. So it will change between 0 and 10. For example, on the second run of that file cache, our seed will be 1.34. On the next file cache, it will be a different seed number for 39. And those values will change between these ones, okay? If we leave the seed here, each time we press render wedge, and we don't change the random seed, for example, the second runtime will always be the same number. So in case that you want to change those random numbers that we got here, you need to tweak this random seed. In other words, you can, if you are just running one time, you don't need to change this. And now we can add as many parameters as you want. Let's add another one. And let's change a little bit our noise, okay? So let's change, for example, the roughness. So let's copy parameter. Let's go to our wedge and paste relative. Clean this up, okay? Let's call it rough. Okay, I forgot the G. And I want this to change between 0.25 and 0.75. Maybe that's way too much. 55 and 3. Okay, and let's see if we want to change another parameter. Let's go with the self-advection. Let's go copy parameter and let's add another one. Let's call it advect. I don't know if this one will do much, but let's see. I'm just trying and improvising on the go. So I want this to change between 0.5 and 2. Okay, so now let's go up. If we press render wedges, it's going to run this, let me see, 8 times. It's going to run this file cache 8 times. But we need to do one thing before we press render, because if we don't change this name, this geometry file name, it will always save the files above or over, write the new file cache over the previous ones. Okay, so we need to add a little parameter here called $wedge. Okay, I'm going with dot to have a difference, and then we need to add this parameter, okay, to tell the wedge to save the files with some information. So each runtime, okay, each of these runtimes, 8 runtimes, will give the geometry file a different name. So in this way, it won't run or write the files over the previous ones. Okay, so after that, it's all done. So check these out, check the parameters all over again. So we have the output driver, you have the number of runtimes that you want to do. So we are going to run this system 8 times and save on files. Change these parameters, the seed, the roughness, and the self-advect, okay? And run them between those parameters. And our file cache as the parameter $wedge on the output file name, okay? That's pretty much it. So now let's save the project and press render wedges. As you can see, we have here, it is running the file cache, so it is saving each frame on my drive, right? And with that name. So if I go, let me see if I can show you. Let's go to Patreon tutorials. Let me go try to show you what we are saving. So as you can see, we are saving the cache particles, right? Underscore wedge, it's the name of our wedge. And then we have the name of each parameter, seed, the value it is taking, the roughness, it's our second, the value it took from the random, and the last one, the advect, okay? So it will run these 8 times, and I'll be right back when it stops, okay? So it took me on my computer, I don't have SSD, so it took a little bit on the second disk. So it took me 8 minutes to save everything else. Okay, I guess with SSD it will run faster. Okay, so now we need to go and pick up that 8 file cache that we just created. So let's go here and press Tab, File Cache. Okay, and if we go here, we can see that we have all the things. Okay, so now let's go with and pick our first one. Okay, let's go load from disk, and if I go here, you can see that I have system. Okay, pretty cool. So now I need to do this 8 times because we know that we have 8. We run this 8 times. So let's go here. Let's pick the other one. Let's go. Oops, I skipped one. Right. Let's go back. And the last one. Okay. So I have the 8 new file cache that we ran with the wedge. Okay, pretty cool. Let me open this up a little bit. Okay, and now I can place a merge and wire everything here. And if I link the merge, put the visible tag, now you can see that we have a lot of particles, and let me see, we have 1 million particles. Pretty cool. And we are on frame 85. We want the last one. Let's go to 150. Okay. Beautiful. And we have 2 million particles. And now I can run and add more file cache. Okay. So let's leave this. Maybe I'm going to run another 8 more 4. Okay. Let's go add 4. And again, we need, like I was saying, we need to switch this a little bit. So if we now run another 4, it will have, because it has the same random seed, this 4 first file cache, it will have the same parameters. So we need to change this seed and press render, and now these random values will be different again. Okay, but for now, for this tutorial, let's leave it at this. And as you can see, with just 8 minutes, okay, we had 2 million particles, right? 2 million particles. And if we want to achieve 2 million particles just by doing the system, we need to come here and increase this number, okay, and it would take more time than 8 minutes. It would take maybe 30 minutes on my computer or more. As you can see, it's a really difference between those systems, okay, these little tricks, these workflows. Time is precious on our area, so we need to work faster all the ways possible, okay? So right now, imagine that we want to still change a few things here. There is another advantage here on this with this wedge trick, that is that we can put a switch. Okay, let's go with the switch, and we can link just one here and merge to the other one. Okay, so we have two inputs. We have the first one, it's a low res, okay, with just 250,000 particles. And the second input, it's the high res with everything else with 2 million particles. It's a big difference because right now, if we want, we can put a point pop. For example, let's go with pop. Oops, I wrote, we want a point pop. Okay, and we want to add colors. Let's go back to our low res. Okay, and let's go, for example, the edge. Let's use the edge to color our particles. Let's put a fit. Okay, let's wire this so our value will be the edge, and it goes from 0 to the maximum. And I want this to go to a ramp. Okay, and this ramp to a color. Okay, this way we can play and add new colors. Let's go add quickly a few colors. Let's go this one, going to be a darker one. Okay, let's go like this. Then I want to go to a little bit of green, then yellow. Now let's go to a darker one, something like that. Okay. We didn't change the life, so on our point pop, let's disconnect this one and let's promote this parameter. Oops, not that one. Wrong click, the source max. Okay, let's call it max life. Okay, and go max life. Let's go up, and with this value, we know you can change that range. Okay, pretty cool. We have 150. This is, I'm working with 30 frames per second, so I know that is 5 seconds. Okay, but I want lower. Okay, something like that. That's pretty cool. And I want the center to be white. I think that's cool. Let's increase this a little bit. Something like that. Okay, that is cool. And we are working pretty fast. As you can see, I'm switching colors, and I can even come and add another point pop. Let's keep adding some more stuff. And let's place another flow noise. Let's randomize. Let's go 3D to 3D noise. Let's add, okay, let's displace these particle positions. Okay, like we did previously on our PopNet. And now I want to offset this. Let's go with a random number. Okay, let's go with 5. Maybe this I want 2. Maybe I want to a little bit 0.4. Maybe 0.6 on everything. Oops. 0.6. And as you can see, we are working pretty fast here with this low res. Okay, we have a really nice system. And when we are ready to check how it looks at the final one, just change the switch back to 1 to use second input, and it will use the high res number. Okay, this way, imagine that you have 30 million particles or something like that. Moving these parameters, as you can see, it is taking a little bit more time to process. Okay, as you can see, I'm changing this parameter and it is lagging. So these little adjustments that you are going to do along your work, it will affect the time and the speed that you can deliver a work, right? So it is good to always try to get better and fast results. Okay, something like that. Go with something like that. That looks pretty cool. And now let's go with no. Let's go out particles. Let's switch this back. Okay, pretty cool. So we have a lot of particles. Now, I know that I want more particles, so I'm going to change this seed. Okay, go to 16, something like that. Let's go and call it wedge second phase. Okay, cool. And I'm going to render this again. So I'm going to add another 16 different file caches with different values. Again, change this random seed to be different from the first one. So I'm going to run this again 16 times and be right back, just to work on a new and more particle. Looks like a Nebula one. It looks like it's from the galaxy. Pretty cool. So let's add more particles. Let's go render wedges. Okay, so after just a few minutes, I have the new files and I've already loaded them in. So now, as you can see, I have the low res, okay, with just 250,000. And let's check with 6 million particles. I'm going to save the project and let's check this out. Pretty cool. You can see the difference. And the time it took to save all these file caches was not even a third of it would take with this PopNet. And I don't know if even my computer would be able to handle all those particles with PopNet. So this little trick really helps out this one. So right now, what we can do is just add a P-scale and work with the render, okay? Okay, to render this, I just put a time shift locked on the last frame, 150, okay? Then on particles, on redshift, I put ignore scale attributes because we don't have P-scale. And I put a default 0.005, okay? 3 lights, simple lights, a blue one, a red. Let me try and show you the positions. Okay, simple as that. So I have a blue coming from the right, red coming from the left, and a normal white one just to give a little bit of ambient, far and white. Okay. On the materials, it's just a simple material with a particle attribute. Get to point colors. Okay. Linked to the diffuse, no reflections because we don't need that. We have too many particles that would take a little bit of time to process on the render, and we don't need. And the redshift on the ROP, I have the simple stuff that I normally do. Global illumination brute force, double the brute force, 6 and 1024. On setting samples, I always start with 4 and 512. Okay, and this is the look, and I hope you can see the difference. I'm going to try and show you the difference between them. So this is the high res. Okay, let's check with 6 million particles. Very cool. And the low res, let me see if I can change you. So let me create another snap. Okay, this is taking a little bit of time to load. We go up. Okay, let me take a snap. Okay, on this one, let's change this to low res. And I hope you can see the difference. So this is with 250,000 particles, okay, and this is with 6 million. You can see the difference, and it just took a little bit of minutes to do that. Okay, pretty cool. This system looks so much better with millions of particles instead of few thousands, right? You can see the difference between them. And it took just a few minutes to write all those caches with WedgeNode. If you enjoyed this tutorial, don't forget to hit the like and subscribe button. If you want Toxius to keep doing these tutorials, check our Patreon page and please consider supporting us. Thank you so much, hope you enjoyed this little trick and see you on the next one. Have a nice day and stay safe.